Alright, so now let's get going on the best project of the year, the zombie project. So, we are going to take a look at, basically I'm going to talk about it a little bit and give you some basically an example of what to do to get you going, okay? So, and by the way, this background you're seeing was actually on a poster board from a student who turned it in a couple of years ago. So you can get pretty creative with this. But let's take a look. So this is what you should have in terms of information. If you don't, you'll want to pause it and write this stuff down. You should have chosen a city, and I had a list of cities. So you needed to write down which city you wanted. Check my website for that. If you don't have that information, I'll get that up there for each period. And you'll want to, if there's one on the list that's not on the list that you wanted, you need to come talk to me about that one. Okay? So this is a presentation. So there's a few different things to talk about first. Okay, first you need to know your city and its population. Now that can just take a simple Google search to find it. You want to get the most up-to-date one. Okay, so you need your city and its population. Okay, you also need your 2 rates of infection as an equation in the graph, and the table was given to you, but you'll need to continue it. Okay, and I'll show you those examples. Okay, you need to have how many days it would take the whole city to be infected, and if you can, figure out that date. Okay, then you're going to talk about some of these key features: the domain, all the x values, the range, all the y-intercept, max, min, slope. Okay, and then talk about how they relate to the context of the function. Okay, so all that information needs to be included in your presentation. Now, to help you fill out that information, I have these worksheets that I gave you and that you can get online. So this kind of gives you all the information. At the most basic, you at least have to have these filled out when you present. Now, I would hope you guys go a little bit further, and I'll talk about some places that you can go, or not places, but some programs you can maybe use to spice things up a bit. Okay, so there's different delivery methods. You can go with a poster board, okay, make it bigger, fancier with all this information included. Okay, and you don't have to just, paste those pieces of paper on the poster board. You can write it out, print it out, draw it out, anything else like that. Okay, you can also just do a portfolio, basically, print it out on paper, or just fill it out, staple together, put it in a folder, something like that. Something that you can still show us. Okay, the other would be to use some sort of electronic program, some computer program, PowerPoint or some other software. Those would probably be the most exciting, and being able to add that technology into it. Okay, so you need to pick one of those methods. You need to provide all that information. Okay, then there's a third portion which we will talk about, the Utah Compose portion. Okay, so here we've got a graph that you are going to use to help you, and I put Twila down. I meant to put the city you chose. Okay, and use it for the Utah Compose. Write a story about what happens and have that story match the graph. Okay, so there's the basics of it. So now let's take a look at an example. Okay, so I've got some information here for myself. Okay, and this is the information you need to have to get into it. You need your city. For mine, I'm choosing Beja. It's in Portugal. So I just looked up online, and the nearest I could find date was right here. So that's my population right there. Okay, then you've got 2 sets of data because you're doing it twice. You're doing everything twice, essentially. We've got our exponential table and we've got our linear table. Okay, so you have to do the same treatment to both of them because not only are you applying some of this information with graphs and equations and a story problem, but you are also doing it for linear and exponential, which are the 2 main types of functions that we dealt with this year. Okay, so here we go. And so I'm going to find all this information and show you an example of this information. Okay, so here we go. Okay, so we're going to deal with the linear first, and then we'll do the exponential. So there's my city, and then my population was 35854. Okay, right there. Now, I've got my table here, my days and my zombies. Now, the way I like to think of it, I like to think of my days as the x value, my zombies as a y. So the first thing I'm going to do is I'm going to take a look at this table. Okay, and I could just keep going with this table. It's pretty obviously that down this side I'm adding 6 each time. So it'd be 18, 24, 30, 36, and so on. 42, 48, 54, and 60. And then down this other side, it looks like I'm adding 16 each time. Alright, so I go 20 plus 16 plus 16, so 36, 52, 68, 84, 100, 116, 132, 148, 164, and 180. Okay. So, there we go. So it looks like, now what we're thinking here is we're trying to figure out how many days, so this side, will it take us to get to this population. Okay, so if we look at that, it's going to take quite a while, right? So I may want to kind of skip. So if I notice, from 30 to 60, 30 days, I went up, 80. Well, from 0 to 30, 30 more days, we went up 20 to 180. So basically, every 60 days, I'm going up 180. So, could I do it like this? 60 to 120 to 180 to 240 to 300, 360, and so on. Could I do that? Yeah, I could do that, and then get 260, 340, 420, 500, 580. Okay, and so on. That's still going to take some time, right? So with the linear, the best thing to do is actually come up with your rate of infection, your equation. Remember, linear is slope-intercept form. So we need to find our y-intercept and our slope. Well, remember, the slope is y over x. This is my growth in y over my growth in x. So it would be positive 16 over 6, or if we reduce that, 8 over 3. Okay, which that corresponds with that rate of change. It's 8 over 3. Okay, well, what does that mean? We'll look at our table. The 8 came from the 16, that's the number of zombies. The 3 comes from the 6, that's the number of days. So, essentially, I'm having 8 new zombies every 3 days. Okay? Okay, I could even, simplify that and go 8 divided by 3 to see that decimal, and that would be 2.666666667. So basically 2 2/3 zombies every day. Okay, that's kind of what that context means. But there's my slope. Okay, so I can go f of x or y. I'll do f of x equals 8/3 x plus what? Well, what's my y-intercept? Remember, the y-intercept is where x is 0, where y is 20. So my y-intercept is 0, 20. Okay, so my rate of infection is plus 20. Alright, now, what does that mean, that y-intercept? Well, that means on day 0, the first day, we already had 20 zombies. Okay. we go. Alright, now, so I can keep counting, and I could even go from 0 to 300 and say, how many, and start adding that many at a time. I could keep doing my table like that. But with linear, there's an easier way. We want our population to be on the y value. So what if we take, or the f of x, what if we take that's like our population, and go set that equal to my equation. Can we do that? Well, yeah, we can do that because I'm trying to match up my population with the y, with the f of x, with the output, and I want to figure out x. So if I plug that in, okay, you're essentially answering this question. If I have, this point, how many days to get me to that? So we'd start out by subtracting 20, subtract my y-intercept, so 3, 5, 8, 3, 4 equals 8/3 x. Then I'm going to times everything by 3 to get rid of that 3 because it's a dividing 3. So 3 times 3, 5, 8, 3, 4 gives me 107, 502 equals 8x. Then we divide by 8 to get rid of those 8's. And this is going to tell me how many days. So it's 13,437.75. So, almost 13,438 days. So in my table, that's what I've got. 13,437.75 gives me 35854. Okay? That's when everybody is turned into a zombie. So, that's how many days we put up here. And if I really wanted to, I could try to find out exactly what day that is, but I'm not going to worry about that. That's a lot of days. Okay? How many years would that be? If I take that and divide it by 365.25, right, a quarter, it's about 36.8 years, so almost 37 years. So right now I'm 33, so in 37 years, people would be slowly turning into zombies until I was 70. Okay? Pretty interesting. Alright. So that would be, 2015. So 15 and 37 would give us 12. So it would be 2052 when that would happen, when that whole city. Okay? Alright. So we've got that information. We also need to do a graph. Now, one thing you can do is go to Desmos, and if you have your equation, you can type that equation in, and then, print off that graph and use that. That's, use that technology to help you out. That's fine by me. But if we're doing it by hand, we'd have zombies, and then we'd have days. Okay, now, looking at my scale, I'm going through a lot of days, right? 13,437. Okay, so what I'm going to want to do is probably, scoot this down. Maybe put 38,000. Okay, or no, it's 13, not 37. So maybe do this last part right here would be 14,000. Okay, and then I could see each one of these, how much they're going to be. Now, you don't have to put a ton of points on here. You just need to do enough so we get the general idea. So there's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 20, 30, 40. I'm not saying every number out loud because that's just weird. 50. Okay, there's 60. So if I take 14,000 and divide it by 60, Each one of these is about 233. Okay, days. So each of those squares stands for 233 days. Okay, up until I get to there. Now, could I write more in? Yeah, I could. Now, for the zombies, we need to do the same thing. Okay, so our population was 35,000, so maybe one of these up here, I'd put at 36,000. Okay, so let's count to a good number. So there's 10 right there. 20. So I've got 30 on mine. So if I made 38,000, it would mean about each one of these is 1,266, each of those boxes. Okay, so then I'd graph it. Well, I'm going to start 0, 20 would be clear here. This is 38,000. I was slightly under 38,000, slightly under 14,000. So it would be, you know, somewhere right about there. And honestly, with 2 points is enough to show my growth here. So there's my equation. Now, what you have to remember is that each one of those squares stands for 233 going this way, for this way, 1266. So pretty quick, or pretty slow, okay, because that's a lot of time. Now, we can take a look at some more of these features of functions. So domain remembers all the x values. Well, according to my situation, less than 0 doesn't work, so I would start at 0. And then, according to my situation, once we hit our population in this many days, that would be the end of my domain, right? Beyond that, I don't really care. So that would be my domain. 13,437.75. So what does that mean? You know, total number of days people are turning into zombies. That's what it means according to my information. Now my range, that's the y values, right? Once again, this is the y value where I start, so that makes sense that it would start there. According to my story, a range could be bigger or less than that, but according to my story, that's where we are. And then that would be where we stop, 35,854. Okay, in that context is, you know, number of zombies. We go from 20 to 35,854. Okay, maximum. What would my maximum be? Well, that point where we stop would be the maximum. Okay. In the contextual meaning, that's when the days equal up to population. Okay. When our population is at that maximum point. Okay. The minimum, that would be the 0, 20, right? It's where we start. The least amount of zombies. Okay? So there we go. So we've got the linear done. Alright? Got everything then. You're just going to take this information, whether you put it electronically, whether you do it on a poster board or portfolio. That's the information all filled out for linear. So our linear would be done, so now we just need to do exponential.